Alright guys, so to start off light, should be a lot of high school review, but if you guys want it, I'll be doing 2.1, which our main goal is to define displacement time and average velocity. So the first things first, we have to know that we have three space dimensions and one time dimension. And however, when we start off, we're not going to be worrying about all three space dimensions. To make things simpler, to give our definitions, we're going to be only working in one space dimension to give us some definitions. So let's say I had a person right here. He is at point x1 at time 1, and he were to move to point x2 at time 2. Now, firstly, by looking at this, we have to define what is x1. And when I say that, when you have normal graphs, that's a bad line. When you have a graph, you normally have 5 being 5 units away from the origin. In physics, we always care about the reference point. We're always worrying about our frame of reference. So we're going to define here this as the origin. And here being x1 and x2 distance away from the origin. So, to start off, let's just define displacement. Which is a change in position. It is defined simply as delta x. Or, in this case, this person's displacement would be x2 minus x1. This is not to be confused with distance. Distance is amount traveled. For example, and this is a scalar and can never be negative. Displacement can. For example, if this human were instead to go from x2 to x1, x2 is larger than x1, so x1 minus x2 would become negative, which is smaller than 0. However, distance would be the absolute value of x1 minus x2. That is distance. Also, for displacement, all we care about is the starting position and the finishing position. For example, if I were to have a racetrack, a circular racetrack, that's not much of a circle. Yeah, I were to have a circular racetrack, this will have to do. And I were to have, this has a circumference of 2 pi r. And a car were to travel the edge of this, starting from here. So the car were to start here, and it would end here. Now, its displacement would be decided by, okay, well, it started at this point, it ended at this point. So it's the point x, so it started at x, it ended at x, displacement equals 0, right? However, for distance, what we actually care about is the distance traveled, or the amount traveled. So in this case, the amount traveled would be 2 pi r because it traveled across the entire circumference of the circle. That is a basic definition of distance and displacement. But then we have to start talking about average velocity. Now, average velocity, if you aren't familiar with the term, is something like we always confuse with speed. And I'm assuming everyone here would know speed. Speed is distance over time. Your car is traveling at 50 kilometers per hour in the road. Normally, that's how fast it's supposed to go. That's the speed limit, for example. However, what separates speed and velocity, which in notation the speed has no hat while the velocity does, is that speed is average change in distance over change in time, while velocity is change in displacement in change of time. The reason this matters is because velocity is a vector. We only care about where we start and where we end. We do not care about how we got there. We don't care if, for example, if I were to travel from this point to this point, we don't care if I traveled this weird jagged path here like this. All we care is that we got from here to here, so this must be the displacement. And therefore the velocity must be like that. How? So to give an example of how we'd calculate velocity, if you remember this man who moved from x1 to x2, it would simply be change in distance, okay, change in position, okay, which is displacement. So velocity of this person equals x2 minus x1. That's a change in position over the change in time. Right. Now, that should be all you need to know to understand the definition of displacement, average velocity, and time. And oh, I did forget to mention that this is velocity. This is the definition of velocity. This is the formula for velocity. However, when you take it in this context, it's considered the average velocity. The reason that's important to mention is because he could have started off going at 50 kilometers. This human, he started off running at, I don't know, 10 meters per second. From here to here, he was going 10 meters per second. Then from here to here, he decided to go 5 meters per second. Then from here to, and then till his destination, he decided to run 10 meters per second. We don't know his actual velocity at each point. We can just decide the average velocity it would take to go there